Everyone, happy Friday. Sorry I can't be with you guys today, but I'm at least here in spirit, I guess. So you had a chance to work through lesson 3.7 with your tables. We're going to debrief this. So what I'm actually doing here is I'm using some responses from A Day, right, since I wasn't able to capture your responses, and I'm going to debrief it with you guys, but using their responses. Okay, so question number one, we're drawing this kind of arrow or flow chart to create what's called a completely randomized design. Now I know it already says it there in the question, but go ahead and add it in the margin of your notes. All right, that what we're outlining here is a completely randomized design. Now this is the simplest type of experimental design that we use in AP Stats. Okay, and you'll notice in question 2 and 3, we kind of add on some extra layers that make the design a little bit more sophisticated. All right, so the most important thing in this completely randomized design is, actually let's kind of go through it. So there's 5 phases, right? We describe who the subjects or experimental units are. Then there's a phase that involves some sort of random assignment. There's the formation of multiple groups, in this case just 2. There's the assignment of treatments. So one of the groups is going to have a in-person teacher giving them SAT prep, and the other group is going to just prep online. And then the final phase involves looking at some sort of response variable and comparing the values of that response between the groups. So in this case, we're comparing SAT scores. So one part I want to highlight here is the groups. Okay, so after the random assignment phase, when we've created these 2 groups, at this point in the experiment, the groups are roughly equivalent. Okay. Meaning that there's nothing systematically different about the groups. Okay, there might be slight differences just due to the random nature, but there's nothing systematically different about these groups. Okay, it isn't until we actually assign the treatment that we impose something that makes the group systematically different. Okay, but here in this middle phase, they're about the same. All right, let's go ahead and move on to the second question. So now what we want to do is we want to basically try to control for the fact that some of the students are seniors and some of the students are juniors. Right? In a completely randomized design, we might get bad luck, and maybe a lot of the seniors get assigned to group 1, just due to the random, unpredictable nature of a random number generator. And maybe a majority of the juniors get assigned to group 2. Okay. That's not what we really want, but it could happen just by random chance. All right. And if it were to happen, now group 1 is mostly seniors, and they are all getting the teacher-led instruction. So if that group does end up with higher SAT scores, we won't be able to isolate the cause to the teacher or whether they were mostly seniors. Okay. So in the second design, what we're trying to do is make sure that the seniors get evenly split up to the 2 treatments, and the juniors get evenly split up, so we don't have any imbalance in the groups that we're forming. All right, so we have the flow chart here, and essentially it's basically like we're running 2 mini experiments. So we're doing an experiment just with the seniors, and then we're doing a second mini experiment just with the juniors. Okay. This is called a block design. Okay. And right at the beginning, when we separate the students by their grade level, okay, these subgroups are called blocks. Okay. Now, don't get confused with strata. So strata is a term that we use for groups of a population when we're sampling. Blocks is a term that we use for subgroups of experimental units. Okay, so these are not strata. Okay, we call them blocks. Yeah. Now, one important thing to note is that when we form the blocks, it's in a non-random fashion. We're not using randomness to create these groups of seniors and groups of juniors. We're creating it using our own prior knowledge of the students. Okay. When we form the groups over here to decide who gets what treatment, that involves random assignment. But the formation of these groups here at the beginning phases does not involve any randomness. All right. The third design wants us to try to account for the fact that these students, specifically we're going to look at the juniors, all have different GPAs. And so we want to make sure that GPA gets evenly balanced to the two treatments, right? We don't want all the high GPA students to get, say, one treatment and all the low GPA students to get another treatment, because that's going to lead to confounding. Okay, we want to make sure that GPA gets evenly balanced out. All right. So here was an idea. Again, this is from A-Day. So they kind of took the approach from number 2, but instead of using grade level to create blocks, they used GPA to create blocks. So they said take the 30 juniors and separate them by their GPA. So group together all the 4.0 students, group together all the 3.0 students, group together all the 2.0 students. All right. A-Day is very kind because they assume that there's nobody who has lower than a 2.0. How nice of them. But anyway, so now we've got 3 subgroups based on GPA, and now we can take all the 4.0 students and then randomly split them up to the 2 treatments. We have our 3.0 students that are getting randomly split up or kind of balanced out to the 2 treatments, and then all the 2.0 students get evenly balanced out to the 2 treatments. Okay. Now, this is a great design. Okay. It incorporates the same ideals of question 2, so it uses blocking, but we can actually do much better than this. Okay. So instead of grouping together all the students with 4.0, why don't we just take the 2 students with the highest GPA? Okay. So in other words, what I'm suggesting is we rank the students first. So create a ranking list, right, from student with the highest GPA on top, student with the lowest GPA on bottom. Okay. And then we'll group together, or essentially pair, the 2 students with the highest GPA. Okay. Now remember, we're trying to balance out GPA. So we don't want these 2 students to end up with the same treatment. We want to split them up so they get different treatments. So we're going to rank the students, we'll pair them up based on their GPA, and then each pair will get split up. One will go to each treatment. Okay. So the way this looks, I have to describe it. It's really hard to draw a flow chart for it, but we take the 2 students with the highest GPA, and then we can flip a coin, right? And then the coin will decide which of those 2 students is assigned the teacher treatment and which of those 2 students is assigned the online treatment. Okay. And then we move down our ranking. So now we're going to take the 3rd and 4th ranked students, right? They're going to have similar GPAs. And for them, we'll toss a coin again. And that coin toss will decide which of those students gets the teacher treatment, which gets the online treatment. And then we move down our rankings, repeating that process for every pair of students until we get to the bottom of our ranking. And so now we're at the 29th and 30th ranked juniors by GPA. We'll toss a coin, and that coin toss will determine which of those bottom ranked students gets the teacher treatment and which one gets the online treatment. Okay. So essentially, we're creating blocks of size 2, right? We rank them, and then the rankings determine the blocks or the subgroups. Okay. So this type of design that involves ranking, pairing, and then splitting up the pairs is called a matched pairs design. So this right here is the matched pairs design. So what the student response is that's just a block design, the 4.0, 3.0, 2.0. Okay, but if we rank, pair, and split, that's going to be called a matched pairs design. It's actually going to give much more precise estimates, much more precise results. All right, so on to the back side. I'll fill in the important ideas with you. So if you hadn't had a chance to read the success criteria, there were 2 skills that we were trying to focus on in this activity. Number 1, describe a completely randomized design. So that was question 1 from the front page. Number 2, describe a randomized block design. So that was question 2 on the front side. And a matched pairs design. That was question 3 from the front side. All right, so we talked about these groups called blocks. Okay, so when we're designing experiments, if we create subgroups of our subjects first, before we do the random assignment, those subgroups are called blocks. Okay, they're experimental units that are similar in nature. So we blocked all the juniors together because they should be similar, and we blocked all the seniors together because they should be similar. All right, so when we use blocking, the name of the design is now called a randomized block design. Right. And so we separate the subjects into those blocks or subgroups first. All right. And it's really important to point out that this separation occurs in a non-random fashion. Right. We're not, randomly assigning somebody to be a junior or assigning them to be a senior. They are already in those grade levels. We're using our prior knowledge, human element to create these subgroups first. Okay. And then after we've created those subgroups or blocks, then we use random assignment to create the groups that are going to receive the treatments. Okay. So there's really like 2 phases of grouping going on. So in the first phase, we'll go back at this question number 2, right? We're creating groups called blocks, and then in this later phase, we're creating groups that are going to receive the treatments. Finally, the third design is the matched pairs design. Okay, and this was the one that I had described as ranking, pairing, and then splitting. Okay, now there's actually a couple different formats for the matched pairs design. Okay, the one that I discussed, the ranking, pairing, and splitting, is how you normally see it done. Okay, so subjects are paired together, so they're basically put into blocks of size 2, and then you randomly assign treatments to those 2 pairs of subjects. You see a lot of matched pairs design that use identical twins to form the pairs, especially medical studies, right? I've, over the past couple of years, I've heard lots of radio ads from Stanford University that they're trying to recruit identical twins to take part in studies that they're doing on that campus. So that makes sense, right? Identical twins would make the perfect candidates, the perfect subjects for a matched pairs design, because they are, for the most part, as identical as you can find among, human beings. Now there's a second format that's used for the matched pairs design, and that involves taking each subject and instead of pairing them with somebody of similar rank, you just pair them with themselves, right? And when you do that, then that means that they have to receive both treatments. Okay. So one way that could happen for like that SAT study is maybe we plan in advance that each student is going to take the SAT twice. Okay. During their first attempt, we will provide them with, say, online instruction. And then in their second attempt, we'll provide them with the in-person instruction. Okay. So now each subject has taken the SAT twice, which means we have 2 measurements from every subject. Okay, and then we can kind of look at the difference in their scores. Did they do better with the SAT, with the online class, or did they perform better with the in-person class? Now, if you do it that way, the treatments have to be given in a random order. So some subjects are going to get the in-person treatment first and the online treatment second, but other subjects are going to get it in the reverse order. All right, so at this point, I'm going to go ahead and end this video, and you guys are going to spend a couple minutes working through the application problem at your tables.